This is Algebra 2, Unit 10, Lesson 13 on solving rational inequalities. Now, we solved rational inequalities back when we did quadratics. What we had to find was the values of the zeros and then where the values are positive or negative to see if it's greater than or less than 0. And we do the same thing with rational inequalities, but there's a couple of things we have to be aware of. So let's take a look at solving a couple rational inequalities dealing with these kind of problems. All right, so let's consider this first one. We have consider the rational inequality x minus 5 over x plus 3 is greater than or equal to 0. Okay, so what we want to do is compare this fraction to 0. Can it actually equal 0? Well, let's see. Yeah, it can. At what x value could it equal to 0? Well, remember, in a fraction, what part of the fraction can equal 0 and have the value equal 0? It would be the numerator. So the value of x that makes the numerator 0 would be x minus 5 is equal to 0, so x would have to equal 5. So, can this actually equal 0 according to this inequality? Yes. So that is part of the solution set, so is this part? Yes, it is. Okay, so 0 is going to be included in this problem. Okay, now remember, with rational inequalities, we can have something as undefined. Where do we have to look to figure out if something is undefined? At what x value is this ratio undefined? We have to look at x plus 3 on the denominator. What value of x will make that undefined? Well, if x plus 3 is equal to 0, that means x would have to equal negative 3. So, is this value part of the solution set? Can you have something that's undefined? So that is no. So our critical values that we are going to have for where our zeros are, we're going to have an actual 0, which is x equals 5, and we're going to have an error where it is undefined. All right, so let's take a look at this in the calculator and look at the table. All right, so before we enter this in the calculator to look at the values, let's plot what we know so far. We have found two critical values. We know that x minus 5 over x plus 3, if x is equal to 5, it makes it 0. So one of my critical points is going to be 5. So 5 is right here, and it will be included in my inequality. Now, x plus 3 makes this undefined. The value of x equals negative 3 makes it undefined. So negative 3 will also be a critical point, but it is not included. Okay, now 5 is included because, remember, the inequality was x minus 5 over x plus 3 is greater than or equal to 0. So it can equal 0, so that's why 5 is included. Okay, now, if this is greater than or equal to 0, what kind of numbers are we looking for? We are looking for positive numbers. If this inequality's got to be greater than 0, we are looking for positive values. Okay, so now these are my critical points. I have to look between negative 3 and 5 and the values around them. So, if I go to my calculator and I want to enter these, you go to my y equals screen. All right, now there's two ways to enter a rational inequality. If you use a division as a division problem, x minus 5 divided by x plus 3, you have to use parentheses for the numerator and denominator. So parenthesis x minus 5, close your parenthesis, divided by parenthesis x plus 3, close your parenthesis. All right, the other way to enter it, I'll do it both ways so you can see it, is using the alpha key. Alpha y equals, pick number 1, so it looks like a fraction. And when you do it using the alpha key as a fraction, you don't have to put it in parentheses. So it's just x minus 5 over x plus 3. Okay, now what's the difference between doing it this way? If you look at your table, let's take a look at the table for this. The one that I answered with the division, notice the numbers come out to be decimals. The one I entered as a fraction using the alpha key come out to be fractions. So that's the difference. You just have to be careful if you use the division. Make sure you put everything in parentheses in the numerator and denominator so that it'll come out as the same answer. So these are equivalent values. This is just the decimal version and the negative version, or excuse me, the fraction version. Okay, so we were looking at the critical point of negative 3. That was my first value. You can see right here this is an error because remember that's the value that makes it undefined. So if this is undefined, all right, negative 3, that is one of my critical points. It can't be included. All right, but if I look less than negative 3, look at my values here. I have positive values. All right, so if I mark my picture here, this section from negative 3 this way is going to be positive. All right, what happens between negative 3 and my other critical value of 5? All right, so my other critical value of 5 is up here. Notice there's my 0 because that's where it equals 0, so that is an included value. All right, now the values between negative 3 and 5, you can see here, are negative. So these values are negative. And anything that is greater than 5, let's take a look. My values greater than 5 are positive. Okay, so if I'm solving this inequality, I'm looking for where it's positive. That would fall in this area and in this area. So this rational inequality has a solution of x is less than negative 3, or, because you have a gap here, x is greater than or equal to 5. So that is your solution set for this problem. So we look for the critical points that make it equal to 0 or make it undefined, and then we plot them and figure out where they're positive or negative depending on the value. So the key to solving rational inequalities compared to 0 is to find values of x that make the numerator and denominator equal to 0. So these are called the critical values. So the rational expression can only change signs at these critical values, because if it's equal to 0, on either side it's going to be either greater or less than it. So we have to know what the zeros are. Okay, so let's look at a little more complicated rational inequality. We have solved the rational equality x squared plus 3x minus 4 is less than 0 over x squared minus 6x plus 9 is less than 0 for all values of x. All right, so show your solution on number line and state solution either interval or set builder notation. Okay, so we have to know what the zeros are in the numerator and what the zeros are in the denominator. Well, if we have x squared plus 3x minus 4 in the numerator, and we want to know where it's equal to 0, we have to factor it. So that is going to be x and x. Factors of 4 that after 3 would be plus 4 and minus 1. So x plus 4 is equal to 0, x minus 1 is equal to 0, x is equal to negative 4, and x is equal to 1. Those are the values that make the numerator 0. So the numerator is x plus 4, x minus 1. So if this is negative 4, that'll make this whole denominator 0, or numerator 0. If x is 1, it'll make this part of the numerator 0. Multiplied together makes them 0. Okay, then we have x squared minus 6x plus 9. That, we want that equal to 0. So that's going to be x and x. Since it's plus here and negative here, it's minus minus. And the factors of 9 that give you 6 would be 3 and 3. So it's x minus 3x minus 3. Now that means that my denominator, x minus 3, is equal to 0. That means I have a double root here. X is going to equal 3. So this is actually x minus 3 times x minus 3 is less than 0. Okay, so what are my critical values, and can they be included? All right, so these are the numerator ones. This is the numerator. All right, so my critical values for that are negative 4 and 1. Now the next thing we have to know is, are they included? All right, so negative 4 is here and 1 is here. Are they included? Well, remember this is less than 0. If it's less than 0, does it include 0? No, so it's not included. All right, so these are not included because it does not equal 0. It can be 0 in the numerator, but since we're looking for the values less than 0, we don't want to include them. So open circles for each one of those. Okay, for the denominator, it's x equals 3 makes it undefined. Now, we never include the undefined. Not included. What makes a fraction undefined is not included because that is an error. So 3 is over here, and it's open circle, so it's not included. So we have 1, 2, 3, 4 regions to check. All right, so what we need to do is go to our calculator, and we want to put in our equation. Now, you can either put it in this way or in the factored form. I'm going to put it in this way because it's a little quicker to type. So if I go to y equals, I'm going to clear these out. All right, and I have x squared plus 3x minus 4. I'm going to put it in as an alpha key, so it's easy to put in. All right, so it's x squared plus 3x minus 4. And then in the denominator, it would be x squared minus 6x plus 9. Minus 6x plus 9. All right, and then I want to look at my table, and I want to look at the critical values of -4, 1, and 3. All right, so looking at my critical values, I got to go back to -4. All right, so here's -4, there's my 0. If I look at the values that are less than -4, all right, because I'm looking at this area right here, if I look at those values less than -4, I can see that they are positive. These are fractions that are positive fractions. Okay, so this area is going to be positive. From -4 to +1, let's look at those values. All right, so there's -4, and I'm going up here, and you can see these values are negative. When I get to 1, that's my other 0. All right, so these values are negative. What happens between 1 and 3? All right, so there's 1, and there's 2 is positive, and then 3 is the arrow, but you can see between 1 and 3, it's a positive value. So this is going to be positive. And then greater than 3, let's take a look at that, is also positive. Look at that. All right, so that's also positive. Okay, so what area are we looking for in this problem? Well, we are looking for less than 0. So less than 0, we are looking for where this is negative. So where is this negative? It is negative between -4 and 1. Okay, so in a solution set for this, the x value falls between -4 and 1. And if you remember your set builder notation, this is set builder notation. If you remember your interval notation, you could also write it like this. Starting at -4, not included is a parenthesis, comma, 1. All right, so the whole trick to this is getting the inequality compared to 0, and then figuring out where your zeros are and where your undefineds are in this problem. All right, so if you have a single algebraic ratio compared to 0, then it's pretty easy. But it's a little more difficult when it's not equal to 0 and you have to get it there. So let's take a look at this. We want to solve this inequality. X over x minus a is less than or equal to 5. All right, well, in order to compare this, it has to be compared to 0. So we have to move this 5 over here. So we're going to minus the 5. So that gives me x over x minus 8 minus 5 is less than or equal to 0. So there's my 0 that I needed. Okay, now in order to compare this, I need this to be a single fraction. So I have to combine these. Now, since I'm subtracting two fractions, technically this is 5 over 1, I need a common denominator. Remember that will come back to haunt you? So x minus 8 is going to be my common denominator. Now this one is already x minus 8, so that's just x. This one I have to multiply by x minus 8 here and here. So I'm going to take 5 and multiply it by x minus 8. All right, now I'm going to combine my denominators, x minus 8, and combine my numerators, x minus 5x, and then plus 40. Because negative 5, remember, distributes through the whole thing. All right, when I combine my terms, I end up with, I'll go up here, x minus 5x is negative 4x plus 40 over x minus 8 is less than or equal to 0. Okay, so now this is a single fraction. I can figure out where my zeros are. Now the zeros, I know the critical point for the denominator will be x minus 8 equals 0. So x is going to equal 8. That's going to be one of my critical points. And since that's in the denominator, it is not included in my value. So x equals 8 would be right here. All right, and it's not included because that's the denominator. All right, now for the numerator, I have to factor negative 4 times x minus 10. All right, so the negative 4 isn't going to affect anything, but if I want that equal to 0 for the numerator, x minus 10 equals 0, x will equal 10, we'll make that 0 in the numerator. Now, is the 10 included? Yeah, the 10 is going to be included because it can equal 0. So 10 is going to be included. Let me change this. I'll make this one 10. Forgot which one I was doing here. And I'll make this one 8. So 8 is not included, but 10 is. Okay, so my critical values are 8 and 10. I can't have 0 in the numerator. I can't have 0 in the denominator. Okay, so let's save this for the next class and figure out where the critical values are.